So first we're going to go through chapter 3 is on differentiation, and we're going to look at some of the basic rules. So section 3.1, and these are the basic rules of differentiation. So in this section there's going to be 4 rules that we're going to talk about. And first though, I want to do some notation. So if we have d dx of some function, that just means take the derivative with respect to x. So as I go through these rules, you're going to see that I have d dx, and then the function is going to be in these hard brackets. And I'm also following the notes that I typed up for you in class on Blackboard. So the very first section, it says 3.1. I'm going to be walking through that section with you. So if you want to pull that up, and if you can print it out, it might be helpful. So our first rule is for constants. So a constant, like 7 or 12 or negative 36, well, that would be the line y equals that. So that's a horizontal line, and we know that the slope of any horizontal line is 0. So d dx of any constant is equal to 0. And I had a couple examples. So d dx of 30 is equal to 0. d dx of negative 2 is equal to 0. And then I had d dx of pi to the 5th, which seems kind of weird, but it's just a constant. Pi is 3.14, and then we're taking it to the 5th power. So still just get a real number, so that derivative is also equal to 0. So that's rule 1 when I have a constant. Rule 2 is the power rule. So if I have my variable to some power, I'm going to take that exponent, multiply it out front, and then subtract 1 from the exponent. So if I have d dx of x to the n gets multiplied out front, and then you subtract 1 from the exponent. So n times x to the n minus 1. So for my examples, I have d dx of x. So this exponent, because there's nothing there, is understood to be a 1. So that 1 would come out front, and then I have to subtract 1 from that exponent. So I'd get 1 times x to the 0 power. But anything to the 0 power is equal to 1. So the derivative of x is just equal to 1. My next example, I have d dx of x to the 10th power. So again, that 10 gets multiplied out front. And then I subtract 1 from the exponent. So I get 10x to the 9th power. I have d dx of x to the 1/2. So those exponents don't have to be just nice whole numbers. They can be fractions, they can be negative numbers, it could be anything, but I'm still doing the same steps. So I'm going to multiply the 1/2 out front, and then subtract 1 from the exponent. So 1/2 minus 1 gives me a negative 1/2. So that's my derivative. And then the last one I have on the sheet is 1 over the cube root of x to the 5th. So before I can take that derivative, I needed x to some power. So I'm going to rewrite and it's going to be x to the negative 5/3 power. Negative because it was in the denominator and I need to pull it up. And then remember this fractional exponent, the numerator is always the power and the denominator is the root. So I get x to the negative 5/3. So when I take that derivative, the negative 5/3 comes out front. And then I have to subtract 1 from that exponent. So negative 5/3, and then I'm going to think of that 1 as 3/3. So negative 5/3 minus 3/3 gives me a negative 8/3. And that is the final answer for your derivative. All right, number 3. This is for a constant multiple. So remember when we were taking limits and we had a real number out front, we could just kind of ignore that, take the limit of whatever the variable part was, and then multiply it back through. The same thing is true when we're taking derivatives. We can really just, whatever that constant is, pull it out front, and then take the derivative of the function. Now, we normally don't rewrite it that way because it just makes it longer than what it has to be. But just know that any number multiplied out front does not affect it. So for my first example, I have d dx of 5x to the 4th. So that 5 is just there. And then I'm going to multiply that 4 down. And then subtract 1 from the exponent. So my final is just 20x to the 3rd power. My next derivative, d dx of 7x to the 5/2. Again, that 7 is just there, so I can leave it, multiply the 5/2, and then I have to subtract 1 from the exponent. So I end up with, out front, is 35/2, and then x to the 5/2 minus 2/2. So that's x to the 3/2 power. And then d dx of negative 8 square root of x. Again, square root means x is to the 1/2 power. So I have the negative 8, and then that 1/2 would be multiplied, and then 1/2 minus 1. So that gives me a negative 4x to the negative 1/2 power. And then the last rule for this section is rule number 4. And that's the sum and difference. So if I have a bunch of terms, I really just take the derivative of each term separately. So, different terms, just focus on each one separately. So I have 7x cubed minus 12x squared plus 17x minus 20. So first, looking at the 7x cubed, that 3 gets multiplied out front, so we get 21x, and then it becomes squared because I subtracted 1 from that exponent. Then the next one, negative 12x squared, that would give me negative 24 when you multiply the 2. And then 2 minus 1 is just x to the first power. Derivative of 17x is just 17. And derivative of negative 20, again, it's a constant, so that's going to give me a 0. Excuse me. You notice on this one I have a d dt, so that tells me I'm taking the derivative with respect to t instead of x like I had the other ones. So I have t cubed over 5 plus 2 over t squared. I want to rewrite it because I need just the variable to an exponent. So that is d dt of 1/5 t cubed plus 2t to the negative 2. Now I can multiply out front. And 1/5 times 3 gives me 3/5 t squared. Multiply the negative 2, I get negative 4t. Negative 2 minus 1 gives me the negative 3 power. So those are our 4 rules that we're starting with in section 3.1. Make sure you look at the notes because I have some try it questions on there. And then the answers to the try it are also on there. And then I have an application problem on there. So look at the notes that I have posted in the section. And then there's also homework 3.1 that I opened up on WebAssign. All right.